Hey everybody. Alright, so a couple more problems. And I selected my picture of my teacher. This is Monkey Man teacher, apparently. And a shout out to Jasmine Patel for sending me the video of the cats spooked by the people wearing cat masks. So I saw this and I was thinking, when we get back to school, I have got to teach a lesson in a Monkey Man mask because I don't know, maybe I get the same sort of fearful response from students, like somebody walks in and jumps because they see me in a Monkey Man mask. I don't know. Anyway, so this problem is exactly like the previous problem. I guess there's nothing like repetition to help people learn. Solubility is given, except for this time they gave you grams per 100 mils, which makes more sense. The last problem was grams per 1,900 mils. I was like, what an arbitrary number. What is the KSP? Okay, we can do that. First of all, let's define what it is that we're finding. CE. I know that's per iodate. Solarium? I don't know, some stuff that I'm supposed to know. Breaks up into CE 4 plus 4 moles of per iodate. And so the KSP for that is cation, cat video, cation, times anion to the 4th power. Okay. So if we knew the solubility, then we could say the solubility of the solarium 4 per iodate is solubility times 4s quantity to the 4th. And this is the mistake most people forget, is that we're talking about 4 moles of per iodate per every 1 mole of solarium, and that is taken into account for when they calculate KSP in terms of establishing that equilibrium. Okay, so what is the solubility? Well, again, they assume that the solubility of the salt is equal to the solubility of the cation, which is equal to 1/4 of the solubility of the iodate, but I'm not going to go that route. Let's get rid of that. Let's just concentrate on the solarium that dissolves. Solubility they gave me, I'm going to convert that into molarity. So 1.5 times 10 to the minus 2 grams of this stuff. Notice I said stuff. I'm afraid your parents are going to hear the video. So I have cleaned up my language. No colorful language. Don't want to violate any YouTube terms of service. Just want to do my job. Which, by the way, is bizarre. This is not how I do my job. And I miss you guys. You know why? I need an audience. I am so unfunny without an audience. I have nobody to respond to, no faces to look at. This is awful. So that is 1.8. And I notice I keep making mistakes. You know, I don't have people to correct my mistakes for me while I'm doing this. So getting a little sloppy in my work. And I am too lazy to go back and redo the video. Anyway, so there's my moles. And I'm not going to show you the conversion to liters. Let's just go right to the molarity concentration. So this is going to be molarity moles over liters. And we know the moles. And we know the liters. So this is going to come out to be... Oh man, my math skills are so terrible. What is it? 1.8 times 10 to the minus 4? Look, as lame as this is, I'm going to check it. Oh, my goodness gracious, I was right. Okay, so now they want the KSP. So this is the concentration of the solarium. God, I hope that's the name of that. Let's check. Is that the name of that element? CE. I don't even know where it is on this chart. How did I get a degree in this stuff? Don't even know anything about solarium. My goodness. Anish, where are you to help me? my God, this was like Where's Waldo? Cerium. What was I calling it? I don't know. Hope I was calling it something like that. Cerium. So that means that the concentration of the periodite is 4 times that. So what is that? 3672. So 7.2 times 10 to the minus 4 molar. All right, so now we can substitute that into KSP. Ooh, different color. All right, so my KSP is equal to this nonsense times this nonsense. Again, the mistake students make here is the formula is raise that to the 4th power. So we're going to do that. All right, so 1.8 exponential negative 4 times 7.2 exponential negative 4 raised to the 4th. And I get 4.8 times 10 to the minus 16, or 17 rather. And last time I made a mistake, I put molarity in there. Again, there's units here, and it would be molarity to the 5th. But generally we don't do units. And wow, okay, again, difference in application of sig figs, but thank goodness I got it right because I do not feel like redoing the video. Alright, so again, this was only a little different than the other problem because of the issue that once you got the concentration of the cerium, then you had to turn around and realize, hey, the iodate is 4 times that. Again, that's the common mistake students make, and teachers, I suppose, and I don't know, average human being, basketball players, etc. All right. What is the molarity of instead of periodate, iodate ions in a saturated solution of copper 2 iodate? And they give you the KSP. All right, so on this one, again, the terminology, right? They're looking at saturated. So they think, as soon as you see saturated means we're looking at a system in equilibria between dissolving and precipitation. So we're at the KSP point. So let's set up KSP first. All right, KSP. This thing dissolves and produces copper 2 plus, oops, hey. It's hard to be left-handed. My knuckle hit that. You don't care. Anyway, 2 times iodate. So KSP for this is copper 2 times iodate squared. And in terms of solubility, we're going to call that S and this 2S. All right, so they give me the KSP, and they want me to solve for the iodate concentration. All right, so KSP is going to be 1.2 times 10 to the minus 7, and this is going to be 4S quantity squared. So now I can just solve for S. All right, 1.2 exponential negative 7 divided by 4 equals, and then take the square root of that nonsense, and you get 1.7 times 10 to the minus 4. Okay, so again, I almost fell for the same trap I fell for last time, thinking I had the answer wrong because this does not match the answer on the slide. But that's not the solubility they're asking for. They're asking for the solubility of the periodate, and we said that the periodate concentration is going to be 2 times the solubility. So that'll be 3.4 times. Okay, so what did I do wrong? Let's see. Maybe I hit the wrong button on the calculator. 2S quantity squared. And we're solving for S. And it's 1.2 times 10 to the minus 7. Okay, let me just check, see if I did something wrong on the calculator. 1.2 exponential negative 7 divided by 4 is 3 times 10 to the minus 8. And then we're going to take the square root of that. 1.7 times 10 to the minus 4. And they want the periodate, which is 2s, which is 3.4 times 10 to the minus 4. All right, what am I doing? What is the molarity? All right. I'm going to pause for a second while I figure this out. Hang on.